Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host, meteorologist DT from weatherrisk.com, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about this week in weather. And of course, we're going to be talking about Fiona and Hermine, and then autumn really showing up in mass. So let's get right to it. First, wanted to bring this point up here back on the Twitter page here. This was, I guess, September 18th, so what, 3 days ago, 2 days ago. Saturday, early Sunday morning, did an update on the website about how Fiona is likely to be a threat to Newfoundland, Canada. And then, of course, here's the write up I did on it, just in case you missed it. And that's, there's a reason why I've been saying this, and we're going to get to this in a second. So I do think this is a serious threat for them. Now, here's the evening update. We can see this from early. This is late Wednesday night, early Thursday morning. Notice the pressure is 935 millibars. On the recon flight here, we can also see on the data. And you have to excuse me if I have to clear my throat here a little bit. I'm suffering from allergies a little bit. All right, so in the latest recon, you can see that if you look at the red line here on the left, the pressure was down there. You can see 930 millibars at one point, 935, and the blue line here on the left hand side shows the maximum winds, which is around 90 knots, something like that. And then of course they are getting some reports. You can see there's one suspected data point of over 120 knots at the surface, but they think that's probably not correct. There is a lot of wind just above the surface here. This is one of the drop sounds. You can see only at 925 millibars, which is only 1,000 feet up, and you can see the winds are 135 knots, 140 knots. So there's a lot of wind really just off the surface here. So the system looks very good on the satellite picture. You can see it. This is from earlier. This is around 9 o'clock this evening. You can see incredible banding with the system. Very impressive. Full scale category 4 hurricane, no doubt about that. And there it is a couple hours later. Not much change. Perhaps not as much black cloud banding here, the white clouds done on the latest satellite picture, but that's maybe just a diurnal fluctuation here. Now most of the models take Fiona, as you can see, or Fiona, takes it paralleling the east coast, and then they hook it due north as it approaches the eastern portions of Nova Scotia, and then into the St. Lawrence Bay, over Prince Edward Island, maybe western Newfoundland, and then up into Labrador. This would be Saturday, Sunday. Of course, as it does that, you can see that some of the models have pretty high winds here in terms of what the actual highest winds are going to be. But there's quite a bit of uncertainty as to what the wind field is going to be on some of these models, because what happens is, of course, the water up here is much colder once you get north of 40 degrees. So even though the water is very warm, the temperatures are not really typical of supporting tropical systems. You can see that also here. This is the European Ensemble, and you can see the European Ensemble projections. Notice around 950 millibars, most of them. Some will even call lower than that, and we'll get to that in just a second. But you can see where the landfall is definitely in the eastern portions of Nova Scotia. On the European, this is from the 18Z run. Now, if you look at the projections from the hurricane models, okay, you can see what I'm talking about. Here, up to 48 hours, it stays at Category 3 hurricane, Category 4, 120 knots. And then once you get to 60 hours, which is, I guess that would be Friday night into Saturday, it begins to drop, begins to weaken significantly. So that by the time we get to, I guess this would be, into the weekend, you can see it's on main landfall to become a tropical, just become a large low pressure area. So my point here is that this is probably too fast a decline, and I'll explain why I think so in a minute. Now this is the sea surface temperature map, Anomalies, and you can see how warm it is in the northwest Atlantic Ocean. This is record warm water here. This pool of extremely warm ocean water temperatures, let me call my arrows so you can see what I'm talking about here. This has been going on now for several months, and this warm water goes all the way to Europe, Ireland, and Great Britain. And it's one of the reasons why they've had such a very, very warm summer and a very dry summer in Spain and France and England and Germany, because you've been getting these constant ridges of high pressure. And as I discussed in the last video, having high pressure in France and Spain produces northeast winds, which causes upwelling down the coast. So you're getting your tropical waters off the coast of Africa have not been very warm, and prolonged northeast winds also allow the Sahara Desert dust to become a bigger problem that lasts a lot longer. Now, recently that has ended, which is why we now have an active hurricane season, because the heat wave in Europe has ended and we're back to a normal pattern. But in the Northwest Atlantic, all this super warm ocean water temperatures relative to normal, anywhere you can see 3-4 degrees centigrade above normal here. So what happens is that now we'll take a look at the models. Now this is from early this morning. This is early on Wednesday morning. The operational European model had a 928 category 4 or 5 hurricane. If you can believe that, hitting eastern Newfoundland, eastern Nova Scotia. I think that's Cape Breton Island right here. I think that's the eastern island there. And there's Prince Edward Island right here. But you can see, let me call it up here, you can see what I'm talking about. Yeah, there's the Cape Breton Island, I think, and there's Prince Edward Island. And this is Nova Scotia here, and this is Newfoundland, in case you don't know your Canadian geography. So that's a category 4 or 5 hurricane at that point. I mean, it's just massive. Okay, well, sometimes models do strange things. Let's look at some other data. Now, this was the 6Z European. This is after landfall, 938. So before landfall, it was around 927. And so this is Saturday morning. This is tremendous. And of course, these are the 10 meter, the winds at knots at 10 meters above the ground, 35 feet above the ground. And you can see, very strong winds here. These are sustained winds. Now the system has come inland. And here we can even see, this is the 6Z run. That was, this is actually one before it. Sure, this is at landfall. So I got those two slides mixed up. So this is early Saturday morning around 4 a.m., 5 a.m. And you can see 927. I mean, God almighty, that matches the 0Z run. I mean, it's almost identical. Look at that. Holy crap. This would be the most intense ocean low, I think, maybe hurricane, to ever hit eastern Nova Scotia. I can't recall anything else. I'm looking at the records. I can't find anything close to it. Now, again, if this is going over non-tropical waters, why does the system get this freaking strong? What is going on here? Is the European gone bonkers? Look at the wind field. Tremendous. Okay, in case you can't see it, let me call up the arrow again so you can see it. Oops. Let me go call out. Okay, you see the winds here? You see this pink stuff and the white? That's like here. That's maximum gusts of 135, 140 knots. Look at this dark red stuff in it. Can you believe this? 100? Are you kidding me? Are you kidding me? This has to be wrong. This has to be wrong. What is the model doing? Now, if we so we know it's doing this thing, 927, but let's take a look at the ensemble. Surely that's a mistake. But if we look at the ensemble, what do we see? Look at all these L's here. If you enlarge this, let me see if I can enlarge this off the map so you can see what I'm talking about here a little bit. Okay, look at all the L's here. All of these are below 935 millibars, almost all of them. I counted 50 different ensemble members. I counted 35 of them with a pressure below 940 millibars. That's category 4. I mean, some of them are 925, 928. That's almost category 5. Look at this thing. It's gargantuan and doesn't change. Look at it goes inland. I mean, look, it's just moving very slowly. I mean, quite impressive. Okay, now this here was the 18Z European, and here what happens is that this is now, it makes landfall Saturday morning. 18 hours later, it's just cleared into the St. Lawrence Valley, River Valley, the St. Lawrence Bay at 9:48. This thing slows down big time. And there's a reason for that. And if it does that, this is going to even add to the disaster, which is headed for eastern New Brunswick, eastern Nova Scotia, Cape Breton Island, Prince Edward Island, and western Newfoundland. This is a disaster if this is right. And here's the 12Z doing the same thing. You can see, I just wanted to show you what this looks like based upon the operational one. And you can see the amazing support from the European ensemble. All right, why is it doing this? I mean, it's got to be reason, okay? So here is the upper air map for tomorrow morning, Thursday morning. There's our major trough right here, and there's Fiona, you can see it. Now what's going to happen is, because of this ridge here, this trough is going to expand dramatically. It's going to capture Fiona. Okay, so that's what's going to happen here. And then you have this big blocking ridge developing in the North Atlantic towards Greenland. So this ridge is going to cause the trough to amplify. It's going to grab Fiona, and this ridge is going to block it. Let me show you what I mean here. So here we go. This is now early Friday morning. Here comes the trough. It's expanded down the Carolinas. It has grabbed Fiona, and look at the enormous ridge right there in Greenland. Look how much stronger it becomes from here to here in 12 hours. So it grabs Fiona and it pulls it up into New Brunswick and Newfoundland, Canada, and it becomes a gargantuan, devastating storm. There's a close-up of it. You can see how the systems are phasing. I mean, that is just perfect. Look at that phasing. God almighty. Very, very scary. And then the storm races northward at 45 miles an hour, and it merges into this gargantuan system here. This is the 12Z Wednesday European, the operational one, for Friday night. So the upper low and the Fiona merge. There it is, the two systems merging, full phase, and they become trapped as one gargantuan low. That's why the system slows the hell down, because it gets trapped by this. It gets captured completely. Very amazing, very significant development here. I got to tell you, I'm freaking out over this development of this system. Okay, now this is Saturday afternoon, 2 p.m. Eastern Time, 18Z. There's the closed low. You see what's happened here? It's completely closed off. I'm talking about right here, so you can see it. Look at this. It's completely closed off. Okay, completely closed off. The two systems have now phased into this. Now here comes the next system coming in underneath behind it. You see this low? This one is a piece of energy. It's coming over the ridge, and it's going to carve out a big trough here for HERMINE, which is this system here. This trough is going to be forced to go underneath it. So Fiona is going to go this way, and then it's going to run into the block, and this system here is by gargantuan closed upper low is going to get trapped right there in Labrador because of this block. You see how the block stops it? And that causes this system to rapidly intensify and deepen. Look, this is a hybrid system. This is not a hurricane at this point. It is not a nor'easter. It's a freak. It's Sandy. It's a freakish storm. It's a hybrid storm. That's what this looks like to me. It looks like that. This system is completely closed off, vertically stacked, stalled over eastern Newfoundland Saturday morning, and that's why the models go freaking apeshit with this system. That's why it's doing this. I mean, holy cow. That's why it's doing it. Unbelievable. And just to show you the point here, the GFS has the exact same thing. Exactly. Not a slight bit of difference at all. I'm telling you, this is going to be a storm. This is going to do some damage. And the worst thing about this is that this is just after the equinox, we have a new moon on Saturday. On Sunday. The 24th and 25th. It's a new moon this weekend. So in summary, just for Fiona, all of the model data shows what seems to be a category 3 or 4 hurricane striking eastern Nova Scotia, western Newfoundland on Saturday. But will it actually be a tropical system at this point? Fiona seems to do what Sandy does back in October 2012. The key is going to be the fast forward speed as Fiona races north at 40 miles an hour and the record warm sea surface temperatures in the Northwest Atlantic, keeping the tropical process going until it becomes the hybrid storm. Fiona is going to get caught in the massive 500 millibar trough on the East Coast that moves from the East Coast on Friday into the Western Atlantic on Saturday. The two features are going to merge into a massive Fiona hybrid system. Now, Fiona is likely to stall Saturday at the time of landfall or just after landfall. And this is going to do several things. First, it's going to prolong the duration of the hurricane force winds slamming into the coast, and then the easterly winds slamming into the eastern portions of New Brunswick, as well as Prince Edward Island, and then also driving the huge amounts of water on southerly winds into western and southwestern Newfoundland. Prolonged exposure to that side of thing. There's going to be maybe 2 or 3 high tide cycles if this thing stalls. and it's going to be right after the equinox with a new moon. Not good, not good at all. This is not good. And then Fiona will become a massive deep closed upper low at 500 millibars in southeast Canada, which will impact the development of Hermine October 1st or September 30th, October 1st, or what have you. Okay, let's go on to Hermine, what's going to become that. This is from September 20th. This is the director of the National Hurricane Center. Even they're looking at Hermine and worried about it. They never put out stuff like this. This is from their Twitter page. This is a system known as 98L. That's what it is right now. So right now the system is officially known as 98L. That's the name of the tropical system. That's this system right here, 98L. There it is on the evening update. You can see from the Hurricane Center the high probability it's going to become a tropical system. No doubt about that. Now, right now, it looks like shit. Now, you can see the curvature bands here. So we can see some curved bands. Look, you can see the curved bands here. You see how the bands are curving here, the cyclonic curvature. See this here. But the system is located very close to the north coast of South America. And that is always a problem because it sucks in dry air from off of Venezuela and Colombia into the system in the southeast. So systems in the southeast Caribbean never develop. And the models, meteorologists, they always get excited about the system here. And once it comes in south of 15 degrees north latitude, it's too close to South America and it pulls in too much dry air. So it never develops there. And look at the infrared. You know, doesn't look like much in the infrared. And it's better on the visible and the overnight satellite because you can see more there. Now, here's the development. Notice they don't show much development now, the hurricane models, through 48 hours. Then it finally begins to develop, and you get a category, 1 or 2 hurricane for most of the models are showing that. Let me show what I mean. Now, this is early Wednesday morning, okay? Now, look at this is now for valid early Sunday morning. You can see where the hurricane is. There it is, right there. Okay, 993, right? Look at the same time, 6Z Sunday morning, right? Okay. Now, this is 12Z Sun today, 12Z Wednesday. Valid, same time, 6Z Sunday. Look how much weaker it is. Here, here. Early Wednesday morning, Wednesday afternoon. Early Wednesday morning, Wednesday afternoon. Why? Because the model's now seeing that it's going to take a long time to get started as it pulls away from the north coast of South America. That's why. Now, eventually you can see all the models turn it into the open Caribbean. And again, just in case you haven't realized this, let's see if I can do this here. You go. So see how close the Caribbean is right here? Now look how much wider it is here at the Gulf of Panama. That's why you always get better development in the Western Caribbean than you do here. That's why. But again, so here is this is the GFS Ensemble. They all take it through the channel up into the eastern Gulf of Mexico. And so do the hurricane models. Now, some of them take it in the Yucatan, but most of them, as you can see, don't have it going Yucatan. Some do, but the majority have it going through the Yucatan Channel or Western Cuba. See that? Both of them do that, and I think that's probably correct. Now, here are the European ensembles. Same sort of thing. Notice, again, very close to the north coast of South America. It doesn't do anything. It gets in the Caribbean here at, this is 84 hours, and then at 120 hours. Which takes us to, I guess, the 26th. You can see the morning 26th, a big cluster of concentration here in the Northwest Caribbean. South of Cuba to the north, to the west or southwest of Jamaica, northeast of Nicaragua. And then you can see here. Now, this is in the upper left. This is 168 hours valid for the 28th. Notice that most of the L's, you can see the L's here, are in the eastern Gulf of Mexico. A few of them go into the Western Yucatan Channel or the Yucatan Peninsula. Most of them are up here in the same thing. Again, you can see headed for the central Gulf Coast or coastal Florida, and then some even have it going east of that. Again, there's a few outliers which have it going in Yucatan. That's a possibility. I don't think it is, but it's a possibility. Now, let's take a look at what's going on here. So, this is the same map, only 6 hours later, that we saw earlier from Fiona. Now, here is Fiona. There's the big F. You can see it. I drew it in there. There it is, a monster closed upper low, strong low pressure at the surface, and a very strong upper low in the jet stream. See the huge block in Greenland? There's your negative NAO. That is a massive blocking pattern in Greenland, which goes into northern uh, uh, Labrador and Baffin Island. Classic negative NAO. And because of this system here, this low right here has to drop southward. See that? Now, if this was winter, this would be a snowstorm. This would be a big ass snowstorm for the East Coast. This system would drop down to the North Carolina coast, develop here. This system would block it, and there'd be belly high to a tall dog in snow from North Carolina to Boston if this was winter. It's not winter, but okay, that's the impact of this block right here. There's Fiona. This system has to go underneath it. See that? Now here comes Hermine. Okay. Now the system, that trough here goes boom, amplifies dramatically, and it grabs Hermine. You can see the base of the trough is so close to Hermine that it grabs it and pulls it northward. Again, notice the block here, right there. See the block? These things are so important. Ridge here, block here, monster trough there, Hermine. There it is. Look at the phase. Bada boom, bada bing. Right into Florida, right up the trough, and you have this huge block right here in the Western Atlantic Ocean, preventing this from going out to sea. This thing is going to block it and force it up the coast, just inland in some capacity. And we can see that here. Now, this is the GFS. This is 138 hours out. You can see it. So actually, I got these systems mixed up here, the images. So this is what happens after here. There it is, grabbing it. You can see the Hermine coming northward now, getting attracted by the trough. Enormous block here in Greenland. And then we get to this. Now you have your full phase. This is now Wednesday night, Thursday morning, landfall in West Florida, or maybe the Florida Panhandle, somewhere around there. And then it goes right up into the trough, along the East Coast. And we can look at this by the different models. Okay, here's Wednesday. This is the 12Z European operational run. Category 2 or 3 hurricane, borderline 2 or 3. It has hit western Cuba, now moving to southeastern Gulf of Mexico. There it is. And here's the cold front. There is a cold front running right here. You can see it. Right on the isobar. See, there's a front right through here. There's big high pressure right there. But that's where the front is. So it's going to move right along the front. That front's going to act as a pathway. There it goes, Florida. 973. Right? Category 2 hurricane. Florida doing its stuff, and then it runs into the high pressure. Now the high is now in the Midwest, so look at the pressure gradient developing here. Look at this, howling winds, heavy rain, the northeast winds here, and then finally on the European, it moves into Georgia, and you have an enormous high. I mean, see, you can see it right here. I didn't draw it in, I should have. A very strong high, 1030 millibars right here in New York State. So look at the pressure gradient here. So this is October 1st. What this means is that in Virginia and North Carolina, Maryland, Delaware, probably into Pennsylvania, West Virginia, Georgia, so on and so forth, especially north of the low, you're going to have a northeast winds coming off the ocean, heavy rain, cloud cover, temperatures in the 50s and the 60s. It is going to be autumn. And this is going to be at this point, Hermine will be a classic coastal storm transitioning to a coastal storm. And it will bring a lot of rain to the southeastern states and up to a good portion up the East Coast. The 18Z Europe, I think this is the GFS. Let's take a look at the GFS solution now. Now the GFS is a little different because what happens on the GFS is it's slower. The operational GFS has Hermine. You can see here going, as you can blow it up a little bit, and you can see what I'm talking about. You see where it is? It's not like Cuba. Look how close it is to Yucatan. So that's a bigger distance here, so the trough swings by and misses it. See what it does? And you'll see that in a second. See how the trough lifts north? Bring front, here you go. See how the trough goes way to the north? Hermine is still down the Yucatan Channel. Now this solution is wrong, okay? This solution is complete bullshit, but that's what the operational GFS is doing. And then you can see, now it makes landfall. It still has it turning north, okay? But it moves into a ridge, and what happens is it stalls over Alabama and Georgia, which you will see here. Here is the European 12Z Wednesday. There it is, 960, category 2, maybe 3, leaving the northeast tip of the Yucatan, headed for Alabama, Mississippi, and there it makes landfall, okay, on the Florida, Alabama coast, and a very nice significant hurricane, not the biggest or worst hurricane of all time, but very significant. A lot of rain. And then what happens in the European and the 18Z, it turns it now into Georgia. So what happens is, here's the European for October 1st, and here's the 18Z GFS October 2nd, the 3rd. So it's delayed a little bit, but it does the same idea. Heavy rain, southeast coming up into Virginia, Maryland, West Virginia, maybe eastern Kentucky, Tennessee, depends on the track. And then by this time, notice now what the GFS does, the 18Z now shoves it east. And so you can see heavy rain all the way up the East Coast. So this solution, again, kind of looks like the European solution, up the upper air map. So, and we can see that. I didn't post the 18Z upper air map. I already have 50 slides here. So, but you can see what I'm talking about. It's a pretty significant system. All right, anyway, so in summary, the tropical waves in the far southeast Caribbean never develop due to the proximity of the north coast of South America. That restricts any and all tropical cyclones, tropical waves, tropical depressions. They don't get it. It pulls in dry air from off the coast, gets entrained in the system, which restricts the growth. Now, once 98L moves into the central and northwest Caribbean, it will develop fast. Synoptically, conditions seem to be ideal. The shortwave trough that drops into the Midwest on September 26th and 27th will rapidly amplify. And as it expands and becomes more powerful as it reaches the East Coast, it will turn HERMINE north. No doubt about it. The question is how soon, how fast. A wider turn towards Yucatan Peninsula is possible. I think it'll make a sharper turn, but I don't know that yet. The key will be the massive ocean low that was Fiona in southeastern Canada and Labrador, which will determine how deep the trough on the East Coast gets on September 29th and 30th. The GFS shows a slower and wider turn than the operational GFS. Taking HERMINE to the central Gulf Coast October 1, the European is further east because it sees the deeper trough with more detail than the GFS does. That's the only difference. The GFS, the European, CMC all take HERMINE into becoming a major rain event once it moves inland, up through the southeast states and up the mid-Atlantic coast. They all do that, and I think that solution makes sense to me. All right, that's the video. It's been a long, I know, 25 minutes talking a lot, but suddenly after no hurricanes, we got a lot of activity. This is meteorologist DT from Weather Risk. I'll see you on the website, the Facebook page, and over on the Twitter page.